Hello and welcome to In Simple Terms with Satish. Today we are talking about biometrics, the tech that knows it is really you. Let us start with the technology first. Biometric authentication uses a signal from your body such as a face, fingerprint, iris, or voice to decide whether the person using a device is really you. At first, it can sound like one clever feature, but the real story is a system of sensors, models, rules, feedback loops, and trade-offs that has to work in the real world, not only in a demo. Let us understand this with a simple everyday example. Think of a bouncer at a private event. A weak bouncer only checks whether someone looks roughly familiar. A better bouncer checks the face, listens to the voice, notices whether the person is actually present, and follows a guest list without keeping a full photo album of everyone forever. Biometrics need that same balance. Recognize the person, detect fake attempts, and protect the sensitive identity data. Now return to the actual technical concept. Under the hood, the stack has several parts. First, capture, where a sensor collects a face image, fingerprint pattern, iris signal, or voice sample. Second, feature extraction, where software turns that raw signal into a compact mathematical template. Third, secure storage, where the template is protected instead of treated like an ordinary photo or password. Fourth, matching, where a new live sample is compared with the stored template using a threshold. Fifth, liveness detection, where the system tries to reject photos, masks, recordings, or fake fingers. Sixth, fallback and policy, where passcodes, lockouts, payment rules, and privacy boundaries decide what happens next. That list matters because modern technology is rarely one model or one app screen. It is usually a chain. Data has to be captured, interpreted, checked, acted on, and corrected when reality disagrees. For engineers, the useful idea is this. The practical pattern is local, protected matching with liveness checks and narrow permissions. The system should prove identity without spreading reusable biometric data everywhere. The catch is that biometrics are convenient but not secret in the same way passwords are secret. You can change a password after a breach. You cannot easily change your face or finger. That is why storage, device security, liveness, and fallback policy matter. This is why the topic matters for students and builders. The visible product may look simple, but the engineering work is in the hidden boundary conditions. What happens when the input is noisy? What happens when the user behaves unexpectedly? What happens when the system is confident but wrong? What gets logged, reviewed, updated, and rolled back? A good way to learn the topic is to sketch the pipeline. Draw the input signals on the left, the decision or prediction layer in the middle, the user-facing action on the right, and the failure modes underneath. That one diagram will teach more than memorizing the buzzword. The clear takeaway is this. Biometrics are not magic recognition. They are a trust stack. Sensor, template, secure storage, matching threshold, liveness check, and fallback rule. In simple terms, the magic is not the label. The magic is the system design underneath and the discipline to know where the system works, where it fails, and how humans stay in the loop. If this helped you understand the topic in simple terms, follow or subscribe to In Simple Terms with Satish. I will see you in the next episode. A useful way to test your understanding is to ask what the system knows directly and what it only guesses. The gap between measurement and inference is where many failures hide. Another useful question is, who owns the decision when something goes wrong? The model, the sensor, the operator, the policy, or the product design behind biometric authentication and liveness checks? That is why good engineering explanations should include the happy path and the messy path. The messy path is usually where the real architecture becomes visible.